Hello class, how are we today? This is part 2 of our inequalities video. In the first video, you learned how to read and write inequalities and graph the solution set. Today, what we're going to learn about is how do I solve them. Okay? So, in this video, we're going to learn to solve one-step inequalities by adding and subtracting, and in a few moments, we're going to get to multiplying and dividing as well. Okay, so the first thing I need you to understand about an inequality, just like with equations, in order to get the letter by itself or to isolate the variable, we add things to both sides, and we typically add its opposite. So in this particular slide, what it's saying is when you add or subtract the same number on both sides of an inequality, the resulting statement will still be true. So here's my statement, -2 is less than 5. So if I were to add 7 to both sides of this, I would end up with 5 is less than 12. Both of those are true statements, and that's the same process that we use in order to solve equations. So I have a big question for you. Do you think we would solve an inequality the same way you would solve an equation? Well, the answer is, well, maybe if I were to get the arrow, the answer is yes. Okay? So let's see if we can solve some. Okay, so this first one says n minus 7 is less than or equal to 15. Well, if this were a regular equation, you know the first thing I'm going to do is I'm going to take care of that minus. So I'm going to change this subtraction to addition and the 7 to its opposite. Now, since this previous slide said that we solve them exactly the same way, we need to isolate that variable. And how do I do that? I add the opposite. That is correct. So I need to get rid of this -7. I need to move it to the other side. So we do n plus -7 plus positive 7 to get rid of it is less than or equal to 15. And if I add something to one side, I must add it to the other. Okay, so now we simplify each side. My 7's go away. I'm left with n is less than or equal to, and then 15 plus 7 gives me 22. Excellent. Now, we talked about a solution set in the last video, that this n can be any value that fits within this solution set. It's not just 22. Okay, so I can have any value that is less than 22 to make this true. Okay, so whenever I'm checking this, just like we did in an equation, we would take the value, we would plug it in, okay, to see if it actually works. In this one, I need to pick a value that's part of the solution set. Now, when it says equals, we never use the equal to value, never use 22, because it will always be true. Always use something as part of the less than or greater than set. So in this particular one, there's one number that I know is part of this solution set that is perfect. And an easy way to actually see the solution set is if you graph it. So I'm going to come down here and I'm going to put a closed circle on 22, and I'm going to shade to the left because I need the values that are left of 22. Now when we look at our number line, that tells us some numbers that are part of the solution set. And one of those that's always good to use if it's part of the solution set is 0. So I'm going to take this 0 and I'm going to plug it back in. Okay, 0 plus -7, is that less than or equal to 15? Well, 0 plus -7 is just -7. So is -7 less than 15? Yes, it is. So this is a true statement. Let's try another one. Okay, this one says a minus 10 is greater than or equal to -3. Okay, so again, I'm going to do the same thing. I'm going to change subtraction to addition next to its opposite. And then I need to get rid of that -10. And how do we do that again? We add its opposite. So a plus -10 plus its opposite, positive 10, is greater than or equal to -3 plus the positive 10. So we end up with a is greater than or equal to 7. Okay, so let's graph it, and then we can see what numbers are part of our solution set. So we come down here to our graph, and it says a is greater than or equal to 7. Uh-oh, I don't see a 7. Where would that be? Oh, that's right, between the 6 and the 8. There's your 7. Sometimes on a graph, the numbers aren't there, and you have to be able to interpret the graph. So because it is a greater than or equal to, I'm going to put a closed circle, and I need to shade to the right. So I need values that are greater than 7 to check this particular statement. So I'm going to use the first one available, 8. So I come up to the problem. I go back to the original problem. 8 plus -10, is that greater than or equal to -3? Well, 8 plus -10 gives me -2. So yes, that is a true statement. So that one works. Why don't you try one on your own? Okay, here we go. Pause the video and answer this question. Okay, let's see how you did. Okay, so this says D plus 11 is greater than 6. So I need to get rid of that plus 11. And we do that by adding its opposite. So D plus 11 plus negative 11 is greater than 6 plus negative 11. All right, so my 11s go away, and I'm left with D is greater than, and 6 plus negative 11 will give me a negative 5. So in order to check this, I need to check with a value that is greater than negative 5. And again, my favorite number is in that solution set, 0. Okay, so I come up here, I check 0 plus 11 is greater than 6. Is that true? Yes, it is, and that is how we answer addition and subtraction problems. So now let's talk about multiply and divide. All right, well, let's review some equations first, just to kind of make sure we understand what we're doing. So in this first one, I've got 4x is equal to negative 12. So that means I have a multiply by 4. So how do I get rid of a multiply by 4? I do a divide by negative, or not negative 4, what am I doing? I do a divide by 4. Sorry about that. Okay, so if I divide one side by 4, I divide the other side by 4. And we end up with x is equal to negative 12 divided by 4 gives me negative 3. And we could plug that in and see if it would work just like we did with equations. And we find out that only one value will make this one true because it's an equation. Now if I have a divide by 5, how do I get rid of it? I do a multiply by 5. We end up with m is equal to 20. All right? So when we're solving equations with multiply and divide, we don't add its opposite, we do its opposite. If I had a multiply, we do a divide. If I have a divide, we do a multiply. Well, we said earlier that we do them exactly the same way as we do inequalities the same way we do equations. So what if I were to give you these? Okay, so let's see what happens. So in this first one, I've got to multiply by 3. How do I get rid of it? Very good. I divide by 3, and I do it on the other side as well. I end up with x is greater than 5. Now, before we graph this, I want us to check it. I want us to see, make sure that this one is actually a correct solution set. So it says I need a value that is greater than 5. First one I can think of is 6. So I'm going to do 3 times 6 is greater than 15. Well, 3 times 6 is 18. Is that greater than 15? Yes, it is. Excellent. So to do a quick graph, I'll just put a slash on the graph, a tick mark. I'll put a 5 underneath it. Because it just says greater than, I'm just going to put an open circle, and I'm going to shade to the right. For division, we do the same thing. So this one we have a divide by 7. So I do a multiply by 7. Okay, my 7's divide out. I'm left with r is less than or equal to negative 4 times positive 7 gives me negative 28. So again, I need a value that is less than negative 28. But in this one, because it's division, I need to set another criterion on it. Less than negative 28, but divisible by 7. So the first one I can think of is negative 35. So negative 35 divided by 7, is that less than or equal to negative 4? All right, well, let's see. Negative 35 divided by 7 is negative 5. Is that less than or equal to negative 4? Yes, it is. So now I can graph this, put a closed circle on negative 28, and I shade to the left. So it looks like that we're doing everything exactly the same as what we did with equations. But I need you to remember that check statement is extremely important. So with that in mind, answer this question. Pause the video and come up with an answer. Okay, let's see how you did. So we have a multiply by negative 5. So what do? We do a divide by negative 5. That's correct. And if I do that to one side, I must do that to the other. And you end up with G is less than negative 4. Okay, now I told you to do a check statement. Make sure that we do a check statement. So here I need a value that is less than negative 4 to check it with. Well, one value that works is negative 5. So let me plug that in and see. Negative 5 times negative 5, which is where my G is less than 20. So negative 5 times negative 5, I get a 25. Is 25 less than 20? No, it's not. Well, maybe I just picked a stupid number. Well, let's try another one. Okay? Maybe negative 5 was not a good number. Okay, what if I chose negative 6? That's a number that will fit as well. So negative 5 times negative 6 is less than 20. Well, negative 5 times negative 6 is positive 30. Same result. That seems like a problem, doesn't it? Well, what I need you to understand about when multiplying through by a negative number. When we're multiplying, when you multiply by a negative number, this inequality is going to flip. So let me tell you a story. Okay, think about going fishing. Okay, just imagine you've got a hook on the line and you cast it out, you got some bait on that line, and you're going to reel that fish in. Okay, now as soon as that fish bites that line, a good fisherman's going to pull back on their fishing rod and is going to set that hook. While that fish runs the opposite direction, the fisherman is going to try to flip the fish and move it towards himself. Okay? This little hook on this -5, that is the hook that we're talking about. And this inequality is the fish. So when I multiply through by a negative number, it's going to hook this inequality and flip it to the other side. So instead of our answer being g is less than -4, I need a value that is greater than -4 to make it true. Okay, so if I were to pick a value, instead of it being less than -4, what if I picked one that was greater than -4? And again, in this one, my favorite number is there, 0. So -5 times 0 is 0. Is 0 less than 20? Yes, it is. Well, what if I picked another value that fits inside this one? A value that says g is greater than -4. What if I just chose -3? That would be the first one available. -5 and -3 make +15. Is +15 less than 20? Yes, it is. So what we find out is that if I multiply through or divide through by a negative number, that my inequality is going to flip in the end. Okay, let's try one more. Let's see how we do. Here we've got c divided by -3 is less than 6. So here, how do I get rid of a divide by -3? I do a multiply by -3. So I do the same thing to this one. So my 3's will go away, and I'm left with c is less than or equal to, and 6 times -3 is going to be -18. Oh, but what did we forget to do? Oh, we got to remember that if I multiply through by a negative number, that my inequality has to flip. So my answer should be c is greater than or equal to -18. So if I were to plug in a value that's greater than -18, but divisible by -3, maybe -15. -15 divided by -3, will that give me a value or give me a true statement saying that it's less than or equal to 6? Well, -15 divided by 3 gives me 5, and sure enough, it works. So what we have to remember is that if I multiply through or divide through by a negative number, my inequality is going to flip. And that's how we solve inequalities. Until next